Today we'll discuss the time complexity, big O of n, and space complexity, how much space it takes in the RAM of the algorithm. Here you see that in the push pop or array indexing is constant time, and logarithmic, like already sorted data, use binary search, that is log n, and linear in an array. If you want to find the data, you have to search all the array elements. It is linear. This is log linear, n log n. You will see that's n log n in case of merge sort, and in quadratic, n square in bubble sort, insertion sort, selection sort. We will see n square. Then these are all polynomial algorithm. This number of items at the base, matrix multiplication O n cube, and beyond that, like Tower of Hanoi or traveling salesman problem, it can go up to factorial n. 2 to the power n is Tower of Hanoi, factorial n. It's an intractable problem, very difficult problem, and that's it. And we can compare this like a person running on a girl running on a walking machine. There's a it's O1 like push pop or array. It is very easy, and log in binary search like a difficult. Uh, More is ON like array finding array, and n square is our algorithm like bubble sort, insertion sort, like this. And these are very difficult problems. So basically, what is algorithm? Algorithm is nothing but a set of instructions, definite instructions, uh, step 1, step 2, step 3, and they're very definite instruction, and there must be there's some input, there's some output, there's some finiteness, some definiteness, and effectiveness. There should not be any loop. That is the difference between algorithm and program. Algorithm should not contain any loop. So this algorithm, a problem can be solved by many algorithms like this, and that algorithms will dictate what kind of data structure it needs. The most of the time algorithms we have to, before deciding on which platform we are working, we should define which algorithm we will take with this kind of data, and what is the analysis of algorithm. One thing is time complexity, another is space complexity. The various types of algorithms are there. We can see that greedy algorithm like shortest path, recursive like whenever you do factorial calculation and all, recursive algorithm, backtracking algorithm, divide and conquer like merge sort or dynamic programming algorithm, brute force sorting. We are already discussed, that is bubble sort, O(n) square algorithm, selection sort, insertion sort, and divide and conquer is merge sort, heap sort, this quick sort, hashing algorithm, randomized algorithm, various types of algorithms. And for them, the time complexity, space complexity, we have to find it out. This is a very good book that's called it Coleman or CLR's book. 4 authors are there. The standard textbook. Here we show that is the big O. The big O characteristic. This is the after some n0. The our actual complexity should be always less than that is a big O, and this is big theta. That this is the two theta items. This and actual complexity should go in between this, and that is the big omega, that is lower bound, and actual complexity should be upper. So generally, for all practical purpose, big O and big theta is more calculated, not such big O. It is lower bound complexity. This is data structures in any language and any algorithm. So these are the primitive data structures available, and this is the non-primitive. There are many cases like linear, non-linear, like tree, graphs, and there are some statics which can be always have to be loaded into the memory during the compile time. This is the dynamic, like linked list and stack and queue. This is at that time, and various algorithms choose different types of data structures if needed. And for this, the complexity will be different. The more you're interested that in this presentation, the time complexity of few algorithms, there's come the space complexity, and then the network complexity. We will not discuss here, and not also here. We'll discuss the time complexity. The O1 constant time is like in a stack push pop to get item from array, in C array, that is O1. Linear time, you can find it finding maximum or minimum in array, that is linear time. A logarithmic in an already sorted array, if you want to do a binary search, the already sorted array. N square is typical example is bubble sort, insertion sort, selection sort, the sorting. Exponential is the Tower of Hanoi problem, and there is various graph problems. This can be found. So this slide is very interesting. This is the linear search. There will be always O n. Inside a loop, there is another loop. There is always a loop. One loop you can always say is O n, and there uh, is a loop, but it is always loop is divided by half, by 2. You can always see there is a log n, it's a binary search, and there is a loop inside another loop, no half or all this, no n square, and there is outside loop, and inside loop is divided by half, that is n log n. These are the 4 algorithms, are very interesting. There's O n, finding a maximum minimum in array, O log n in a binary search. O n square algorithm is insertion, bubble sort, insertion, selection sort. N log n is merge sort. This is the advantage of logarithm. Logarithm is inverse of exponential. It is much faster and it's much less. This is a divide and conquer algorithm, 2 types, merge sort and dynamic programming. You will get this merge sort. It is you get it n log n, and in dynamic programming, in Fibonacci number calculation, we discussed in the class, that is gives much more advantages than crude recursive algorithm. This is interesting. That is, we generally denote these terms constant, logarithmic. Remember, this logarithmic is to the base 2. In computer science, 99 of the problem, the logarithmic is not in natural logarithm or 10. It is always to the base 2. Here it is log to the base 10, log squared. Some algorithm is linear. These are the typical name, and you can see it here for particular complexity, so particular data items. Say here, say in 3 years, 3 hours is okay, but 32 years in N2 algorithm for 100k data is impossible. So we have to get it less than S cube. You can see traveling salesman problem, Tower of Hanoi, to the power n, and you can see after n regarding n 50, it is almost impossible. So we have to solve this problem. Factorial much more tougher this. So we'll see that how to make less complexity by various tricks, divide and conquer, randomize algorithm, and dynamic programming. The techniques are there, various techniques are there. This is an example in our last video. This is a bubble sort. We can see that this is the algorithm. You can see it here, a loop inside a loop. This is outside loop, this is inside loop that you have to mark, and you can find it. The algorithm is well square. Thanks for me.